Hi, this is Zephram Tripp from Team DRGBL, working under the BYU Capstone program on the High Bandwidth Memory Interfacing and Monitoring project. As part of our project, we developed a simple GUI for running our test that we created for the high bandwidth memory on the Alveo U280 board. This uses the LiteX terminal and the LiteX server to communicate with the board over UART, and that allows us to send commands using various CSRs on the board, one character at a time, and that allows us to run the various tests for the high bandwidth memory. And I'm going to give a simple example of how the GUI works. So as you can see, I'm already in the directory where we hold our LiteX files. From this directory, we first have to source our Python in virtual environment. This will allow us to access all of the various different dependencies that we need to have our project work. The next thing I need to do is source the Xilinx Vivado tools. You don't always need the Vivado tools for LiteX, but we've chosen to use those tools in particular for our project. So those are the ones I'll be sourcing this time. We use version 2022.2 in particular. So now that we've sourced those tools, we just need to start up the LiteX server. And we do that by running this command. Once we run the command, you can see that the server is working on a particular port. In your particular case, you'll probably have to change which port it's acting on depending on your system and implementation. Then, to activate the GUI, we just run this command to run the script that activates the GUI. So here's the GUI, and as you can see, it has a few different parts and functions. It has a field for the number of bytes to read and write in a transaction. It has the ports that you want to assign to read and write encoded as a binary stream. It has the delay time between transactions and cycles. It has the starting address for the first read and write of a transaction, the address offset between subsequent reads and writes, and the data byte pattern for writes. All these are options that we can set to do various tests on the high bandwidth memory. Then we can either set the assigned ports to read or the assigned ports to write, and we can start the transactions on all assigned ports. We can get the data from them by pausing the transactions and sampling the overall throughput, and then when we're done with the test, we can stop all the ports using the Finish button. If we want to have some automatic collection, the Start Collecting button collects the results every 6 seconds for 1 minute. And the Resize button allows us to resize the graph to fit whatever screen size we have available at the time. So just as a short example, let's say we want to write FFFF bytes to the bottom 16 ports of our machine, and we don't care about any of the other things. So we can just set them all to write, and then we could start it, and then we can get the data. Now it'll take a couple seconds to get the data, but as you can see, we now have 0 data points, so it doesn't create a very interesting graph. But if we get data again and wait a couple seconds, then we can see it's about the same across the 2 samples, and so it creates this straight line on the graph. And then if we finish this test and switch it to reading instead, and then we start it up again, and then we get the data again, then we can see that the reads have a much different throughput than the writes. And so if you collect a bunch of times, you can see those things get graphed over time. And various other settings will cause you to get different results as well. And that's all. That's all the GUI has, except for, I guess, the last thing is the Help button. If you need additional help, clicking on the Help button will link you to our wiki, which has information here on the right-hand sidebar for the GUI tutorial. And that will help you with any other issues you might have with the GUI. Thanks for watching. Hope you have a great day.